All right, 2-2, day 2. Spend one more day here calculating that delta algebraically. 2-2, day 2. Okay, starting off with examples because you already know what the process is all about. If I have f of x equals 3 plus 2 sine of x minus 1. Like I said, the difference today is going to be in the equations. There's some tricky ones. We are going to let x approach 1. We're going to let epsilon equal 0.3. So you have to first, you should sketch a graph, then find the limit, and then find the delta. So we'll sketch, find the limit as x approaches 1, and calculate delta algebraically. Okay, sketch first. Anytime, we're in radian mode all year. Radian, I'm good there. 3 plus 2 sine x minus 1. I'm going to do a zoom trig. Trig sets up a nice trig window. It's number 7. If I wanted to see the top of that graph, I can just increase my Y max on the window up a little bit. Probably 6 if I want to see it. Pretty good guess on my part. Okay, we are looking for the limit as we approach 1. I can trace to 1 to get that. Right in the middle of this upward swoop, 1, 3. So 3 is going to be my limit. That just plugs 1 in there and cranks through that. So the part of the graph I want to see is right here at 1. And we just found a limit of 3. So the limit as x approaches 1 of the function was 3. So now we're going to set an epsilon window equal to 0.3. So I'll go 0.3 above and below. And we will find algebraically this delta value, whichever side is closer, if one is closer than the other one. Okay, so we set up our triple inequality. So it's the limit plus and minus the epsilon. So it's 3 minus 0.3 less than the function and then the limit of 3 plus the 0.3 epsilon. Okay, solving for x in the middle, I'm going to subtract 3 from everything. So 3 minus 0.3 minus 3 more is 3 minus 0.3 minus 3 more. Oh, what's wrong here? Oh. Is a negative 0.3. I was going to say, I'm lost for a second. 2 sine x minus 1 less than 0.3. Whew, got it. Divide by 2. Let's see, negative 0.15 is less than sine of x minus 1 is less than 0.15. Okay, now my x is trapped inside of the sine function. What you need to do to undo this is take the inverse sine of everything. So that means inverse sine is that little negative 1 thing. Inverse sine is right above your sine key. Inverse sine. So when I work this out, if you remember from trig, the inverse sine is right here above your sine. So to get that, use your second function, negative 0.15, and I get negative 0.1506. So negative 0.1506 is less than, what happens here, the sine goes away, I'm still left with the angle x minus 1. And then I'll do the inverse sine of a positive 0.15, and I get a positive 0.1506, add 1. 1.1506 is less than x is less than 1.8494. Okay, I'm going to check. I was approaching 1, both of these numbers. 1's on each side of 1, so I think I did a good job there. Now I just have to figure out, remember this is the x value, delta is the distance away. So where I drew this down, this is at the 0.8494. This one over here is the 1.1506. So to figure out the delta here, we want, the delta is always a distance, it's got to stay positive. So to get the delta here, we're going to go distance away from 1 will be 1 minus the 0.8494. Over here, I'll take this number and subtract 1. So here I'm going to get a delta equal to 0.1506. Over here, 1 minus 0.8494. Same thing, 0.15, so it was symmetrical. Kind of looked like it was going to be. So we found our delta window. Okay, and again, just like yesterday, we want to go through that algebra and carry the epsilon through and show what it comes out for any epsilon. So I know it comes out symmetrical. It doesn't matter which side of this I set up. I'm just going to choose to set up the right-hand side. So I'll do it side by side. Instead of putting in the 0.3, I'm going to put in the epsilon. So it'll be 3 plus epsilon. It's still my limit plus the epsilon is the outside on the integral. Or not the integral, the inequality. First step is subtract 3. The steps are parallel to what I did over here. 2 sine x minus 1 less than epsilon. Divide by 2. Sine of x minus 1 less than epsilon over 2. Now I'll do the inverse sign to get rid of that. So that cancels that, x minus 1. Here I can't do anything but write it down. Inverse sine of epsilon over 2. Add 1. So I get, oh, I'll put an equal sign there. X is less than inverse sine of epsilon over 2 plus 1. Okay, again, I'm at x. I'm not to the delta yet. I took one extra step to get from this number to my delta, and it's right here. And I took the time to write it out because it makes doing this part easier. I know exactly what to do. I'm going to subtract 1 from it. So to get the delta, I'm just going to subtract 1. Those are going to cancel. Inverse sine of epsilon over 2 is my delta. And if I wanted to check to see if I did this right, when I put the 0.3 in for the epsilon, I should be coming back out with this answer. So inverse sine of 0.3 divided by 2, 0.15056, 1506, rounded off. You did a good job. Okay, so you'll be having one with trig functions in it. Number 2. Oh, before we get to number 2, I don't know if you got to logarithms in advanced algebra or not, but there's a property we're going to use in this next one that I want to quickly review. If you have the log base 10 or base anything really of a to the b power, the property we're going to use is the exponent property, which says the exponent can come down as a multiplier out in front of the log. So it becomes b times the log of a. Okay, it's going to come up in this next example. F of x equals 0.5 times 3 raised to the x. we want to approach an x value of 2. And we're going to have an epsilon of 0.2. So the first thing we're going to do is find that limit. Oh, first we're going to sketch. So it's 0.5 times 3 raised to the x. Go back and do a zoom 6. It's an exponential graph, and we are approaching 2, so I'll trace to 2, hit enter. My limit's 4.5. So I'll make a quick sketch. I get 4.5. Okay, so now we're ready for the triple inequality to calculate the delta algebraically. So it's the limit plus and minus the epsilon. So 4.5 minus the 0.2, the function goes in the middle, 1/2 times 3 raised to the x, and then that limit of 4.5 plus the epsilon. I like to take the time to write that out that way, and then it sinks in my brain a little bit better. Okay, first step is going to be to get rid of this 0.5, so we're going to divide by 0.5. So you obviously have to do your subtracting first and then divide. Oh, I hit something. Okay, 4.5 minus the 0.2. Divide by 0.5, 8.6. We have 3 to the x. And then here that's going to be 4.7 divided by 0.5, 9.4. Okay, again, if you didn't get to the logarithms in advanced algebra, when the x, you wouldn't know how to solve this, but when the x is up in the exponent, I always remember this. I learned it actually in college. You have to hit it with a log to knock it down. And I always remembered that phrase he said. I'm like, oh, cool. So if your x is up, hit it with a log to knock it down. So what we're going to do is take the log of everything. So I'm going to take the log of 8.6 is less than the log of 3 to the x is less than the log of 9.4. And how this helps me is now I can use that property that I showed you at the beginning. Just a minute while I turn that off. Okay, so that property that I showed you at the beginning, I have the log of 3 to the x. I can bring that exponent down as a multiplier. Then I'll be able to solve for the x. So my next step is going to be just to take this down out in front here. So I could get the decimal for this right now, but I'm going to wait. The log of 8.6 is less than x times the log of 3 is less than the log of 9.4. So again, this is x times the log of 3. To get rid of that, I'm going to divide. So I'm just going to divide all 3 parts by log 3. And if we did this correct, our numbers should come out around the 2, a little bit smaller than the 2 and a little bit bigger than the 2. So now I'll grab the calculator. Your log button is right here. Log of 8.6. I have to close the parentheses to stop the log there. Then I'm going to divide by log of 3. I get 1.9586. Smaller than the 2, just smaller than the 2. And the other one, log of 9.4 divided by log of 3, 2.0396. Again, right around the 2, I think we did pretty good. Again, those are x's, not deltas. We just found these 2 x values. We need the distance away. So I need to know how far away this is from 2. And to keep it as a positive value, because deltas are positive because they're distances, I'm going to go to minus 1.9586 to minus 1.9586. I get a delta of 0.0414 over here. I'll take this x value and subtract 2. If I do 2 minus that, then I get a negative number. I don't want a negative. 0.0396. So it was not symmetrical. Again, we're going to keep the smallest delta. Okay, and now running through that same problem again. For any epsilon, we know this side does not work because it gives us the bigger delta, so I'm just going to set up this side in place of the 0.2. I'm going to put it for any epsilon and go through these steps. So good practice with your algebra today. 4.5 plus epsilon. Divide by the half. Divide by the half. Okay, I'm going to distribute that to both of them. So 4.5 divided by a half, I think it's going to be 9. Because it's like multiplying by 2. If I divide by a half, like I said, dividing by a half is the same as multiplying by 2. That's 2 epsilon. Okay, if you have questions on that, you can ask me tomorrow. We got to do the log now on both sides. So I got to do the log of 3 to the x is less than, here I got to take the log of the entire side. So it's the log of the quantity. 9 plus 2 epsilon. Now the x can come down as a multiplier. Divide by the log of 3. Okay, and remember, we're not done. We're only at the x spot. We're right here at the 2.0396 if I was to put in the 0.2 here. To get from here to here, we subtracted 2. So the delta is going to be kind of ugly here. It's all of this minus 2. So log of 9 plus 2 epsilon over log of 3 minus 2. Okay, one more. And it's a piecewise graph. So f of x equals the piecewise function, 2 times the quantity x minus 4 squared plus 3 if x is less than 4. And then it's 0.5 times the quantity x minus 4 squared plus 3 if x is greater than or equal to 4. Oh, you know what? I am not going to do this one. We're not going to worry about that one. Otherwise, I'm going to be way too long-winded. Okay, the other thing I do want to do in here is refresh your memory on synthetic division. Because it's a skill you're going to need in, I don't know if it's the next section or the following, but any time in the next 2 sections we're going to be doing this. Again, you should have learned this one in advanced algebra, but I will take the time to review it right now. So we're doing synthetic division. It's 5 steps. I'm going to give you the steps, and they may not make sense until I actually apply them to the problem. The first step is to take the opposite of A in the x plus A binomial. Second, you want to list the coefficients in decreasing powers of x. Third step is to raise the first term. Fourth step is to multiply, add, dot, dot, dot. And then write the answer starting with exponent 1 lower. Okay, none of that makes sense until I take you through an example. And what I hope to do is if you ever forget, you can look back and this will be enough to refresh your memory. So we're going to go through a couple of these. Now this will be example 3. Let's go x cubed minus 5x squared plus 10x minus 8. And if we wanted to divide that by the binomial x minus 2. Okay, we can do this synthetically. This is our x minus a term or x plus a term. And the first thing I ask you to do is take the opposite of a in the x plus a term. So the opposite of negative 2 is positive 2. What we're doing is setting up our Gazinda. That's our division. Gazinda goes into. Now it says list the coefficients in decreasing powers of x. So what I'm talking about is I've got x cubed, x squared, x to the first, x to the 0. The coefficient here is a 1. A negative 5 comes next. Positive 10. Negative 8. Now it says raise the first term. What I mean is this term in here, raise it up. Put nothing below it. Then it says multiply, add, multiply, add. So what we're going to do, the number that I raised up is going to get multiplied by this 2 out in front. So 1 times 2 is 2. It gets written in this next spot. Add. You want to add vertically. Negative 5 plus 2 is a negative 3. Now it's multiply. So I get negative 6. That goes over here. Now add. I get 4. Multiply. I get 8. Add. I get 0. On all of these, you should end up with 0. So it's raise, then multiply, add, multiply, add, multiply, add. So now these are the coefficients to my answer. And it says write the answer starting with exponent 1 lower. So I had an x cubed. 1 lower is an x squared. My coefficient is a 1. So it's a 1x squared minus 3x plus 4. So if I was to take this and multiply it back by this, I would get this back. But we're not doing that. Try another. 2x cubed plus 2x squared minus 7x plus 15. We're going to divide that by x minus 3, or excuse me, x plus 3. So starting out, it's take the opposite of this term, which is negative 3. Make your Gazinda box. Highest exponent first, the coefficient, 2, 2, negative 7, and 15. So it's raise the first one, put nothing below it though, cross that spot out. And now you're at your multiply, add, multiply, add, multiply, add. So multiplying, I get negative 6, adding, negative 4, 12, adding 5, negative 15, 0. So my answer is 2x, 1 lower, squared, minus 4x, plus 5. And we're going to go one more for good measure, and you'll see why in a minute here. I'm going to squeeze it in. I've got x to the 4th minus 16 divided by x minus 2. So, take the opposite here, I get a 2. My highest exponent is x to the 4th, that's 1. But, notice there's no terms in the middle here. I don't have a cubed term, a squared term, an x to the 1st term. I do need placeholders in my division box, so I need a 0x cubed, 0x squared, 0x, and then a minus 16. Okay, now raise the first one, nothing here, multiply, add, multiply, add, multiply, add, multiply, and you'll know you did this right when you get 0 on the end. If you don't get 0, you've got some kind of a mistake in it. They're multiplying or adding, obviously. And now the final answer would be, because this started out x to the 4th, this 1 is representing my x cubed term, plus 2x squared, plus 4x, plus 8. Okay, so your homework today are to do these, the 4 synthetic division on that little, not even a half sheet of paper I gave you. And page 45, we can't do the piecewise one because I didn't do it. You get 10 and, oh, I gave you that one yesterday. Shoot. Should be 7, 10, and 12. I've got to fix that. Okay,